Hello, welcome to Quantum Online Academy. This is your Dr. Nagaraju Pendam. In this video, we are going to discuss about one more important electromagnetic theory question, that is from motion of a particle under the uniform magnetic field. So, motion of a particle under the uniform magnetic field. In the presence of a uniform magnetic field, the particle is in moving in which path you have to see. When this question is asked in CSIR December 2014, this question is asked, this is the based on the pitch. So, what is this? Based on the definition of the pitch. So, what is the definition of the pitch we have to see after some time. So, first we have to take the question. A charged particle moves in a helical path. A charged particle moves in a helical path. This is the helical path. Which path it is? Helical path under the influence of constant magnetic field. A charged particle moves in a helical path under the influence of a constant magnetic field. The initial velocity is such that, so the component along the magnetic field is twice the component in the plane normal to the magnetic field. So, the ratio of L by R of the pitch, so of the pitch is L to the radius of that helical path is capital R is, so what data they are giving, once you have to try to understand, there is a helical path is there. Suppose you have to take a magnetic field into the board, you have to consider. So, this is the magnetic field is there. So, maybe in this direction the magnetic field is moving. Now, this is the magnetic field, correct. So, magnetic field you have to take here magnetic field. Now, one charged particle is moving in the presence of the magnetic field. A charged particle is moving. This is a uniform magnetic field. So, one charged particle is there. That particle mass is m, that charge is equal to q. So, it is moving. So, in the charged particle is moving in the presence of electromagnetic field. In which path it is moving? This path is helical path it is moving. So, which path it is moving? Helical path is moving. Now, you have to resolve into the charged particle. This charged particle moving with velocity v. So, this velocity component making with an angle theta, it resolves into two components. One is the vertical component v perpendicular, so that is equal to v sin theta, and another component is there, that is v parallel. V parallel is equal to v cos theta, right. So, but according to our condition, what they are giving, v parallel is equal to that initial velocity v parallel is equal to 2 into the twice of the v perpendicular. This is the given data from the problem. From the problem we have to write this from the problem, from the data. So, from the data of the problem. So, what is the data of the problem? Once you have to see the initial velocity. So, v parallel, the initial velocity is such that the component along the magnetic field, the component along the magnetic field, the component along the magnetic field is twice the component in the plane, component in the plane normal to the magnetic field, component in the plane normal to the magnetic field. So, that is why what we have to write, v parallel is equal to 2 into v perpendicular. So, but we know the definition of that, how we have to write here. Once you have to see, this is the helical path. Which path you have to take? This path is this path we call it as a helical path, helical path. So, this helical path is the combination of circular path, circular plus straight path. The combination of circular plus straight path, we are going to the helical path. Suppose V is perpendicular to B, we will get the circular path. V is parallel to B, we are getting a straight path. The combination of that path we call it as a which path it is? A helical path. So now the particle is helical path. So the distance between one complete cycle, the distance between one complete cycle or the successive distance of the successive distance of what? The successive distance of two adjacent circles. The successive distance of two adjacent circles we call it as a, so that is the pitch we have to take. Otherwise the distance between the one complete cycle. So what is the pitch? L is the pitch. So the pitch L is equal to the distance between one complete cycle, we call it as a, which one it is? The distance between one complete cycle, that is the pitch. So what is the distance? That is a circular shape is there. So what is this distance? You have to take, already they given the distance is equal to, the diameter is equal to 2r. So this is equal to radius is equal to r is there. So we know that. So what is the formula for the pitch is equal to? So L is equal to pitch. So the formula for a pitch of the helical path is equal to, what is your formula? V parallel into time period. V parallel into time period. So V parallel is equal to, we know that, so 2 into V perpendicular. So V parallel is equal to 2 into V perpendicular, 2 into V perpendicular plus into time period. So time period for a complete cycle. So what is your time period? So T is equal to circumference is divided by V perpendicular. Why I have to take the V perpendicular? Whenever the V perpendicular to B, then only that particle path is a circular path. That's why I have to take it as a V perpendicular. So therefore 2 phi r is divided by V perpendicular. So V perpendicular get cancelled. 2 into 2 phi is equal to 4 phi r, which is equal to L is equal to, this is the pitch of the helical path. What it is? So but what they are asking, the L by r they are asking. L by r is equal to 4 phi. This is your expected answer. Once you have to see your answers based on your answer, what is that you have to see? Option A is wrong, option B is correct, option C is wrong, option D also wrong. So L by r is equal to the ratio of pitch to the radius of helical path is equal to 4 phi. So when this question came in CSIR December 2014, this question came like this. They will ask the questions in your competitive examination. So please try to learn the subject with your problems already. So daily I am informing to you, we started the CSIR and GATE physics course in online mode, right? So I have own app is there. I am only teacher. I only teach all the papers. In the YouTube channel you able to see, we gave the demo of the mathematical methods of physics, classical mechanics, electromagnetic theory, quantum mechanics, all the 9 papers we discussed in that. So you once you see, so many videos I am uploading, daily I am uploading from each and every word. So one topic I am discussing and uploading in our YouTube channel. You listen and decide my teaching. If we really enter into your mind, so you have to download my app. Once you have to download, you able to see the courses in our app, that is CSIR and GATE physics course is there. So not only CSIR and GATE physics course, there is a JL physics content and DL physics content. Not only JL and DL physics content, individual papers also is there. suppose you unable to perfect in the mathematical methods of physics, only mathematical methods of physics you have to take. This course is finished already. So now if you unable to perfect in the classical mechanics, only classical mechanics you have to take. So this course also finished in the classical mechanics. Now electromagnetic theory we started. Electromagnetic theory, so that's why I am uploading the videos in YouTube also from the electromagnetic theory. So here electrostatics already we finished. Electrostatics we finished. So we started the magnetostatics. Right. If you have to take this course, so every day 6 a.m. to in between 8 a.m. there is a live class also you able to see. This is the live only, I am not editing anything. So directly I am recording and I am uploading that one. So I am not anything, clear. So utilize this chance, you have to inform to your friends. So please share and subscribe our YouTube channel. Thank you so much.